Good afternoon, everyone. I'd like to welcome you to this afternoon's presentation. It's Intro to Passivhaus, Build Your Climate Future. With us here today is Jeremiah Point. He is a proud Mohawk residing in the ancestral community of the Akwesasne, and he's also a Passivhaus certified designer. Without further ado, I'd like to have you come up and
thank you. Make sure I start my clock here. I have a presentation as well, slideshow. Welcome, everyone. As mentioned, I'm Jeremiah Point. I'm also a licensed mechanical engineer in the province of Ontario. Operated my own business, Point Engineering, for about 11, 12 years now. And I also have a second company, Nova Commissioning, which specializes in quality control and commissioning of building systems in Eastern Ontario. Between those two companies, I also took on as a hobby housing. I don't work for council. I butt heads with my council all the time. I'm always pushing them to do better. But I always see that better can be done. So I speak ever since I found out about Passivhaus and what it meant and where it came from. And I didn't even know what it was years ago when I was doing mechanical design. It was architect would design a building, give me the plans. Can you design us a heating system for it? And I made a mistake on my energy modeling. And I had put an R value in that's quite a bit higher than what the architect had put on the drawings. And I realized that there was very little heat requirement. Obviously, more insulation means less heating demand. And it dropped significantly. I showed it to the architect after I realized my mistake. And I said, look, can we build this? Like, it dramatically reduces the size of the equipment. It's for a commercial building, but it reduces the size of equipment, reduces energy costs, and you just put the money towards insulation. And I kind of got dismissed. He was senior architect. I was there 6 months. And he said, no, you're crazy. Like, that's going to cost too much money, right? 15 years later, I found out about Passivhaus and realized that I kind of was on the right track there in my line of thought, and saw a lot of correlation with what Passivhaus can do and what it offers. So I got certified as a Passivhaus designer about 3 years ago. And I immediately joined the board of directors for Passivhaus Canada, and I'm ending my third year as my first term. I put my name back in again to be renominated or reelected to stay on the board for another 3-year term. I just feel like 2.5 years of COVID kind of stole a lot of opportunities, and I don't feel like I'm done on the board yet. So something that started out as a hobby with housing kind of turned into so much more and keeps me quite busy. So as an organization, independent from government and agencies, it's a nonprofit. It carries forth the international Passivhaus standard from the Independent Institute in Germany, the Passivhaus Institute, which I'll talk about a little bit more. But great group of people, very helpful, very welcoming. I am the first Indigenous person to be involved, especially at the board level. And the first thing that I brought to the table was the housing crisis that we all suffer from in all our communities and the challenges that we face. Since then, a lot has changed in the last few years, especially with going online and all of those things pivoting because of COVID. But I can't tell you what the issues are. You already know. So we suffer. I'm in Akwesasne. We're on the border of Ontario, Quebec, and New York State. Our community is on both sides of Canada and US border. We struggle with the borders dividing us. We struggle with what building code do we adopt? What building code do we follow? We struggle with getting contractors to come to our community, and we're right in the middle of everything. We have the United States as access. We got Canada as access. Ottawa's an hour north of us. There's quite a few trades and contractors in the area, but we just can't get them to come to our community because there's a toll booth in the way, there's logistics. I live on the island on the St. Lawrence River. Part of our community is still in Canada, but on the south side of the St. Lawrence, and you got to drive through the States to get there. So contractors just refuse to come. The contractors from the States a little more sparse, but they won't come across the border into the Canadian portion of the reserve that's only accessible by the state. So kind of landlocked there. So just because we're close to larger cities and we have access to materials and trades and all that, it's not any easier for us either. We might as well be far up north and have to fly everything in because that's what it feels like. My friend waterproofed her basement. She had to barge everything across the river because the only contractor that would do it was from the Canadian side, because her house is technically on the Canadian side, but you had to go through the States to get there, and the border was closed for 2 years because of COVID. So she paid an extra 20 grand just to barge everything across to get there and then to do the work on top of that. So horrendous. We always look at building codes, but they're not very good. A couple of sessions here today talking about building codes, but they're no good. And then the National Building Code, you can see there, no legal status unless it's adopted. So you choose to take that on and enforce it. And especially with the National Building Code, the enforcement is the engineer, is the architect. Well, if you're designing houses, how do you get an engineer and architect to do that? Like, it's too expensive. So it's all these financial barriers. Doesn't matter what code you use. It's the absolute minimum legal standard for people to not die in your building. Kind of a low bar. I don't feel like that's enough. I feel like we can do much better than that. It's great. I see a lot of the success stories teaching the basic fundamentals for trades, carpentry, building structures that aren't going to fall, that kind of thing. There's one extra step after that. And I've spoken to the Architects Association of Ontario and did a presentation. I've spoken to contractors, builders, councils. Like for the last 4 years, I've been just talking about Passivhaus nonstop to anybody that would listen. And it's always the same thing. Code's good enough, code's good enough, but it's not. And there's a lot of reasons and there's a lot of information. There's a lot of science. There's a lot of data to back that up as well. And what we're seeing is when you're choosing to build to code, and I've seen it firsthand. I worked on the school that they built in Attawapiskat probably close to 10 years now, 10 years ago. And while I was going up there to do the quality control and commissioning for that school, I visited a factory close to Akwesasne, just off the reserve, and they were building modular homes. I was talking about a different project that I was working on, personal project. And I said, I'm going to be in Attawapiskat next week. Well, these houses are going to Attawapiskat as well. They're in production right now. And they're going to house the teachers up there. Well, they were 2x6 construction, fiberglass bats, double pane windows. And it seems so foreign or absurd to me that you're going to build these houses here that is technically code compliant for Eastern Ontario, Southern Ontario, and then you're going to ship them to Attawapiskat. Well, how long are they going to last? Like, it's a losing battle to begin with. And the last presentation I did was in Victoria at the annual Passivhaus Canada conference, and I showed a map. The distance from where the factory is to Attawapiskat was the same as North Carolina to the Canadian border. Now, you wouldn't buy a house in North Carolina and ship it to the Canadian border and use it in Canada. It's just not built for the climate. That's very important because if you don't build it for the climate, it's not going to perform. And it's, of course, we know what the issues are. Codes change, very small incremental changes, and it's just not pushing us to where we need to be. You can see this is for commercial buildings, low-rise commercial buildings, but the same thing, 6% better, 7% better. And I saw a presentation earlier that part of the requirement to access funding is you do 25% better than the National Building Code. Well, Ontario Building Code already does that with SB 12 and the changes that they go through. And then that's what your goal is to meet. But we all know what the result of that. This is what we see when we build to code. You see all the 2x4s when you do the thermal imaging and you actually take a look at it. The only thing separating you from the outdoors is a piece of lumber. You can put fiberglass bats or any kind of bats in there or spray foam or whatever between those studs, but you lose 16% just because it's lumber. The wall is 16% lumber. So you're already losing whatever R value that you purchased to begin with. You got thermal bridging around your doors, thermal bridging around your windows. You got double pane windows, especially if you're shipping them out of Wapiskat. they don't get warm enough for double pane windows. And then as soon as you go to triple pane, which is typically only 5% more money to purchase the windows, the frames become a problem because the frames are thermal bridge as well, especially if you're installing the window frames with the nailing edge that everybody loves. Quick, easy, throw it in, put some nails on it, on the sheathing, and then put the siding over it. But the pane of glass is then moved to the complete exterior where the siding is, and you get a huge thermal bridge around the frame. So how you do it is important. Greenwashing is what I call it. I've heard that term before. Numerous programs on how to make your building more efficient. For commercial buildings, it was LEED. I'm LEED certified as well. I did that before I got into Passivhaus years ago. And what programs like LEED and other programs that are similar is they promoted geothermal systems, they promoted solar panels, they promoted all these high-tech, very expensive solutions. And it made everybody think that energy efficient buildings and high-end buildings are expensive, and they're always going to be expensive. And especially on reserve, where we already struggle with finances to get a little bit of money to build something that might meet building code, and then you're asking them to do more. And it's like, there's just no money for it. In 2019, just before COVID, I was going through the last few classes of my training to be a certified designer, certified Passivhaus designer. And they spoke in the class about this tradesperson, Passivhaus tradesperson course that was new. They're rolling it out. It was done in Vancouver. It was done in Chicago, New York City, but that was about it. And as soon as I heard that, I tracked down some certified trainers, and I hosted the very first tradesperson course in Eastern Canada, right in Akwesasne in our community at our adult education facility. We had 14 people from my own community attend that class. It was a 4-day hands-on workshop. And I had the housing director from the neighboring community, Ganawage, to come and attend the class as well. As a result, there's been some uptick in paying attention to what these things mean, what Passivhaus is, and attempting to that. Right now, I'm butting heads with council because they're talking about they're building semi-passive. And one of the chiefs, or used to be chiefs, just a couple of weeks ago, he asked me, what does that mean? And I said, it doesn't mean anything. It's not a term. It doesn't exist. They just made it up because they want to feel good about doing passive, but they're not quite doing passive. They're not doing the energy modeling that's required. They're not doing the detailed analysis that's required in the planning stages. The construction side is the same. It's the same cost. And we're seeing that across the world. Vancouver saw it in BC. We see it now in Southern Ontario where they're starting to do passive for luxury homes. If you're going to design a building and build it, it doesn't matter what you build. It's dollars per square foot on average to build something. And I did a 3-story apartment building just off the reserve for a friend of mine they had 3 buildings on the site already, and they wanted to do a 4th, had to look identical to the 3. And they said, would you design it for us? And I'm like, sure, but we're going to go passive. And I couldn't get them to go all the way, but they went about 90% of the way there. Again, they wanted in-floor heating and all that, and it was just an argument. But when they looked at building this 3-story apartment building, they brought in a contractor and said, how much to build one of those to today's standard? He said 1.2 million. This was before COVID prices, of course. And then I designed it and I put extra insulation. We went way beyond triple pane windows. We did all these things to upgrade it. And at the end of the day, it was 1.2 million. It was the same. So it doesn't have to cost more. And part of these programs and the solar panels and everything else is what makes you think that it has to cost more. And when you look at, I think this is called a sustainable pyramid or something like that. Education, optimal home size, air sealing, energy recovery, thermal performance on the air insulation. That's the foundation. It's the cheapest, it's the lowest hanging fruit. It's the easiest to do. It's something you're already doing. Just do it a little bit more and then see the returns on it as well. When you start looking at geothermal systems or heat pumps or solar power or wind turbines, and you start adding those high-tech, expensive solutions, the complexity. How many have put in a biomass boiler or or some other system, and you can't get anybody to service it. As soon as it breaks down, it's done. You can't turn it back on. You don't have anybody who's trained on how to run that system, and it's complicated. So you really got to look at what's at your disposal and work within that. And one of the things that we're learning is it's really simple. It's really basic. You don't have to reach for those expensive technologies first. You reach for them last. So reduce your demand, reduce your dependency first, and then look at those technologies afterwards. And that's what they discovered. This is not a new concept. This is the modern passive house. I'll get to the modern part later. But the first one was built in 1977. They studied it and studied it and studied it, and they created a Passivhaus Institute in Germany after that. And they went on this whole thing to create this whole idea and develop it, review the finances behind it, review the approach behind it, everything. You can get as complicated as you want and as expensive as you want, or you can keep it simple. And right now I'm involved in a certified passive house that's being built just outside the reserve, young builder. It's his third house that he's ever gonna build. It's a third one. He helped build one, working for somebody. He started his own company and built one, and now he's building a second one on his own, and it's a certified passive build. So it's not complicated. It's not something that you got to bring in a specialist. You do need the training, and that's what he struggled with the first build that he did. He didn't have the formal training, and he kept saying he was doing passive, and I had to go meet with him and tell him, no, this is what it means to be passive. And then he understood, and I said, go get trained. So the tradesperson course that I had taught in Akwesasne in 2019, first one in Eastern Canada, because of COVID, it moved online. So I told him, and just like I told the attendees in the first course, I said, you got to get the formal training and you got to get certified. Well, the attendees from my own community, after the class, we said, here's the next exam. It's only twice a year. Get the exam, get certified, get certified. And nobody got certified. This young guy off the reserve, he went, got out certified. 2 months later, he calls me and he says, I took the class online. I took the exam. I'm certified. He's the only one in East Ontario now. What that training gives you is the understanding of what Passive House is, what it truly is. It's science-based. It's measurement verification. It's proven, and it's very simple. And what it does is reduce your dependency, reduce your needs for energy to begin with. Then you can start adding the other technologies if you want, if it's in your budget, or if that's what the desire is. Maybe you have to go off grid because you don't have utility services. But this guy here developed the Passivhaus Institute. They studied it. They produced an energy modeling software. It's a massive Excel spreadsheet. I have trouble understanding it. I try to use it. I struggle with it, but it's very complicated. But that's why you got to work with a certified Passivhaus designer, because they've been trained on how to use this program. And your energy modeling right down to what the thermal bridge is, where you're installing the window and how the window is installed and where it's placed within the wall. So it's very detailed. If you take a wall and you add more insulation, that's only a small piece of the puzzle, because now you got to address the thermal bridge around your window. The more you increase your air tightness, the more you increase your R value, the more humidity could be a problem. The more you have to pay attention to it. The more you might find thermal bridging and frosting and condensation on the window frame. So it's very important to pay attention to all those details. And that's what it comes down to. You're trading off those expensive technologies, furnace and boilers and all that stuff. You're trading that, putting that aside, and you're looking at the very few details, the very minor details around how you build your wall assembly, and pay attention to those details and spend all your time there, because that's what reduces your demand in the first place. You can build a nice building, it can be leaky, and then you pump a whole bunch of heat in it, still not going to be comfortable. And that's what they're finding here, is that making it airtight and more insulation also increases comfort, indoor health quality, and just in general, the health of the indoor environment. While they were looking at increasing the R values and spending more on the building envelope to make it more airtight, to make it higher R values, better windows and doors, better quality materials, they saw the reduction in demand, and there was a tipping point. at you see the 15 there was a tipping point where, okay, that's enough. Because once you get to there, that's where your HRV or your ERV or your ventilation system that brings in your fresh air can maintain the temperature of your building. So the recirculated heat, the baseboards and the furnaces and all that other stuff doesn't have to exist anymore. And it's very hard, especially with that 3-story apartment building I mentioned. They wanted in-floor heating and they wanted it so bad that they put it in and they can't turn it on. Because as soon as they turn it on, it's too hot in the building. They want to feel the warm on their feet, but they got to open the window in the wintertime just to feel it because the building overheats. They get people to come over for a birthday or something and you get a few extra people in there, it starts to overheat. So you run your ventilation system a little bit higher to get that heat out and control that. That's where you're at. The amount of heat generated by your body heat, your refrigerator that's always running anyway, your heat recovery system is enough to keep that building warm almost all year round. And then you supplement that with your warm air from your ventilation system, which you need anyway. And I always struggle with this when people say, you can't build it airtight. The building has to breathe. And you build it airtight, it's going to get full of mold. Yes and no. You want your building to breathe, but you want to breathe mechanically with a unit like an HRV or an ERV so you can control it and it's constant. You don't want it to breathe when the wind blows harder because that's unfiltered air, that's moisture, that's all leaking into your wall assembly, causing mold and rot and mildew, and it causes all kinds of problems. So that's what they were finding when they did this whole study. And then they build a bunch of buildings and they compare the actual energy consumption against the energy model that they created. And you see it follows exactly. When you see the uptick, like this one down here on the right, it's because of the users not closing the windows. They're not closing the windows. It's users disrupting the energy consumption, using too much hot water, taking longer showers, and you see the energy jump, but that's from user base. But the energy modeling is solid and it works anywhere around the world. The reason it works is because when you're doing an energy model, you have to look at your local climate data in order to design the R values for your building, not pick an R value at random from the building code and then stick a furnace in there to supplement where it's falling short. So it's a bit of a reverse. When I did the presentation for the Ontario Architects Association, they asked me, a mechanical engineer, they said, it's always too late. When the architect designs the building and gives it to mechanical engineer, and the mechanical engineer does the energy modeling to determine what size the HVAC equipment or the furnace or heating system has to be. And then you don't reiterate that back into the building envelope design, into the architect's design. That energy modeling has to shift from the mechanical engineers where it's too late in the design and has to be at the front. It has to be at the beginning before you design the building. Why are we choosing building codes, R values from the building code? Because somebody decided that was a good number? Where does that number come from? And these are the questions you got to start to ask once you start to learn more, is that why? Why did we choose that number? What does it even mean? But if it's not, every time a building code comes out, they change it. Well, we got to increase the energy efficiency. And that's what you saw the other slide. They increase it a little bit. They don't want to disrupt the economy. They don't want to upset people. So they just turn up the efficiency a little bit. Now you got to build a little bit better. Ontario SB 12, the latest change was a continuous R5 wrap around the outside of the building on your sheathing layer. So build your house, put the sheathing on, wrap it with 1-inch foam. That's what the contractors do because it meets building code. If you're already spending the labor to do 1-inch foam sheets on the outside, then why not spend the labor to do 12-inch foam sheets on the side? It weighs the same. And there's products out there that can give you that. A single layer, 8 inches thick, you can double it, get 16 inches thick. By moving that insulation to the outside of your building, now that stud wall and that sheathing layer is completely on the warm side of your insulation, and there's no interruptions from the studs. So what ends up being is the healthiest, most affordable, most cost-effective, safest building that you can build, and it's climate resilient. When I talked to my council and I said, look, if we decided today that we're going to build passive buildings and we spend the money on a few designs and then give those to people, this is what you need to build, and they start building them, it's going to get cheaper. The first few are going to hurt because it's a learning curve, but it's not that much. It's like, do what you're already doing, just do it a little bit more. So Once you start down that path, there's no turning back. And we saw in Vancouver, that's what they do now. Richmond, BC, that's what they do now. They're like, we won't build anything else. They went through that growing pain and that figuring things out. And they're like, okay, let's tender this project and let's do, you design build for building code minimum, you design build for passive house, and let's compare the prices. And in the beginning, passive house was 10% higher, which isn't much. 10% is your contingency fund. 10% higher. The second tender, it was even. The third tender, it was cheaper. And it's because people were learning how to do it. And it doesn't have to be complicated. It doesn't have to be expensive. And that's why you see Passivhaus taking out that whole bottom section, being cost effective. It's just approaching it a little bit different. Pay attention to the thermal bridge. Pay attention to where the lumber is penetrating this insulation layer. Move the insulation to the outside of the lumber instead of putting it between the studs, or in addition to putting it between the studs. But as you can see, it starts with education. Diagnosis has to come from your location. And I think the energy modeling requires within a 50 kilometer radius is where you get your climate data. So either you have to create it or you have to import it. So it's very specific to your local climate. It could be different in the mountains, it could be different in the valley, but you have to build it. And you're going to end up, okay, we need R value of whatever, 62 or something in our walls. And then, well, do I build a 12-inch wall or a 14-inch wall? You're probably not going to build a 13-inch wall. So we'll round it up. So you really, at the end of the day, you're working with nominal sizes. And that's why the cost isn't really extensive or super expensive. And if you train it and if you approach it using the materials and the supplies that you have on hand already, whether it's ICF, lumber, or stick frame built, or whatever technology that you're accustomed to, it can be modified as long as you design it from day one to incorporate the Passivhaus principles and then go from there. So doing that energy modeling up front, not to size the furnace, but to size the walls and pick your R value. That's where you're going to get that efficiency. That's where you're going to get that reduction in dependency. The air tightness there, you see one of the 5 principles, the air tightness, you can only do it once. You can't do it afterwards. There's no way to go rip into that wall and make it airtight afterwards. You got one shot to do it, and that's when you build it new. If you're doing a renovation, how do you do it? There's that guy I showed, I can't think of his name now, and it's a shame, but the Passivhaus Institute, they went off and they really focused on new construction. But one of the guys that was involved, he's in his 90s now, his name's Harold Orr, O-R-R. He developed the blower door test that we all kind of seen or heard or used, the blower door test to test the leakage of your building. He invented that. And when they did that first house in 77, and they developed blower door tests, and okay, this is how you test the leakage of a building. The spinoff from there was that they went, the Institute, new construction, they did all that, and Harold Orr said, that's great, but new construction is a small percentage of our building industry. There's a whole slew of buildings that are existing now that need to be addressed, because we're not going to tackle climate change. We're not going to tackle any of this by just focusing on new construction. It's going to take too long. So he turned his focus and he went to renovations. And you can look it up. I forgot to put it in the slide. It's Harold Orr chainsaw retrofit. And basically he cuts off the overhang. He wraps insulation, real thick insulation around the entire building, makes it airtight and insulates the whole building from the outside. And then he attaches the overhang back on afterwards. And they call it chainsaw retrofit because they take the chainsaw, not an actual chainsaw, and they just run down and cut the overhang right off because it's just in the way. It's a thermal bridge. It's just going through the insulation. So, and then they install the Passivhaus windows. So triple pane, huge air gaps between the glass. It literally takes 4 people to lift a normal size window and put it into the opening. It's that heavy. It's like nothing. If you've never seen one, you got to look it up. You got to get one in your hands. Go somewhere where they're selling them. Look at a Passivhaus certified window, because you'll be blown away. You'll be like, it makes North American windows, even the triple pane, look like shed windows. Like they're not even comparable. The windows are operating with an R value of 9.8. Like we have walls that are 9.8 and they're making windows that are 9.8. They're European style, your triple seals. triple pane, all these things, very insulated frames. The spacers between the glass are not metal, they're composite, so they're not a thermal bridge. They bury it into the frame assembly to get it away from the cold. There's all these ways, and then you place it within your wall assembly down the middle to get rid of that thermal bridge as you're doing the construction, but you only got one shot to do it. If you're doing a renovation, you're just spending probably the same money as building new, but you're doing it all over again on an existing building. There's still a cost benefit to doing a renovation. Depending on the building, it's an individual survey that has to be done. But if you have to change your windows because they're end of life, then you might as well put passive in. But I wouldn't rip out windows that have been there for 5 years and put in passive windows. You're just throwing money at the problem. So there's other things you can do. They showed this compact ratio from all the energy modeling, and they looked at the compactness ratio, and they said, as you come down to a more compact living, high-rise buildings or whatever, you got more people, more refrigerators, more kitchens, more activity, more heat being generated within the building envelope. Well, all of a sudden, it's really easy to make it passive. Really easy. Like they did a survey of the high-rise buildings in downtown Ottawa, and on average, based on the energy consumption and the surface area of the exterior of the building, average was R2 for a high-rise building. It was absurd. And then the air leakage on top of that. So it's super easy to do that. Well, when I was in training and I saw that, I was like, what the heck? That's a vertical longhouse. My ancestors lived in longhouses. They figured it out. They didn't burn wood all winter long. You would have to deforest your area. That's absurd. So they put 200-300 people under one bark structure, just bark, but it's warm all winter long from the body heat because everybody's in there. So there was no way you could burn wood all winter long and stay warm. That's absurd. You just burn yourself out. You can't do enough labor to do that. And then you can't harvest enough food to feed the workers. So there had to be a way. They had to figure out a way because they didn't have energy at their disposal. They weren't spoiled with utility grids and everything else. They had to figure out a way for their local climate. And you can see the areas that utilize these types of structures. And you go to any area, any indigenous peoples, we should know better because our ancestors did it. They didn't have all of this energy at their disposal, building wasteful homes. And that's the vertical longhouse. Come on, this isn't nothing. This isn't anything new. It's just using modern materials, right? This is an older graph, 10 to 20% more building costs. That's come down now. But with the education, like I spoke, they're seeing that come down to zero. So if you're going to design it right from the beginning. It doesn't really cost that much money. Sure, you could get drawings for a house for $500, but if you spend $2,000, you have no heating bill, or your heating bill's $100 a year. Well, that's kind of a no-brainer, especially if you're spending money on a furnace. What's a furnace cost these days? 20 grand with all the ductwork and everything else? Well, put that 20 grand into the windows and doors, put it into more insulation, making it more airtight. Because that furnace is going to wear out in 15 years and you're going to have to replace it, service it. You're going to have to feed it with fuel somehow, as opposed to wall insulation that doesn't need anything. Just make it watertight. So that's what we're seeing. The knowledge, the education, the training, the experience gets behind it, and that cost goes right to zero and sometimes negative. It ends up being cheaper. And then you save for the life of the building. I have 2 councils in my community, one on the Canadian side, one on the American side. It's craziness. And I met 4 times with the council on the American side, the tribe, and they're building 19 homes or something. And I said, look, you got to do passive. You got to do passive. And they said, no, we're doing New York State Building Code. That's good enough. And after preaching to them and talking their ear off and trying to convince them, they're not looking at the true cost, because the true cost is not just the construction, it's the home ownership too. It's the operating cost. So when you factor in the operating cost, all of a sudden, it's cheaper to build passive house, without a doubt. Nonprofit organizations, this is what they're doing. They're saying, we can fundraise an extra few $100,000 to build a new building. We can't fundraise $500,000 a year to heat the thing. So nonprofits are all shifting towards this idea of going to passive, build the right building to begin with. Let's not just keep pumping money into it for its entire life until somebody says, oh, let's just destroy it and build a new one. It's craziness. Throwing more money at it. So we know what housing means on reserve. We've seen the studies. We know firsthand. We live in it. Overcrowding, lack of capacity, all of that. When you start looking at passive buildings and eliminating the thermal bridges and increasing that R value, all of a sudden overcrowding isn't really a problem because the humidity isn't getting to the dew point where it's causing condensation on the glass anymore. Because you can increase that indoor humidity higher without compromising the building structure. And it's because you're addressing those thermal bridges, you're addressing those R values, and you're building it for your climate. And you don't have to just overventilate, which is going to cost you more energy in order to dry it out, which is too dry for human comfort. So there's so many benefits that come back, and it's just investing in those static systems. But it's always, you see down here, First Nation managers highlighted need for occupant education and prevention. So it always goes back to education. If we continue to say, what should we build? And look at the building code and take those R values and build it, we're just going to do the same thing we've been doing for how many decades? This event's been going on for 20 years trying to address housing crisis. And it's just the same thing over and over and over, and it never changes. I talk to young people because every time somebody inherits a house, the first thing they do, pump a few $100,000 into it to renovate it, to bring it up to today's standards. Well, what is tomorrow's standard? We already have a climate change emergency that's declaring building emissions that have to be a certain level for 2030. Well, guess what those targets are for energy consumption for those net zero buildings or net zero ready or whatever you want to call it? It's passive house. That's the level. That's where we need to be. And if we're building new buildings, then we need to be building passive buildings today. We need to be doing them 20 years ago. And when I renovated my house in 1998, I wish I'd known this stuff. And that's why I talk about it so much, because it's a missed opportunity. If only I had known back then what I know now, I would have done it completely different. I wouldn't have renovated the way I did. I would have renovated it to be a passive building. And then I would never have to renovate it again. We always hear the same terms, especially from where I'm from, Haudenosaunee people. We make decisions for the 7th generation, but we don't make houses that last 7 generations. Christ, they don't even last 1 generation. They don't even last 10 years. And I told my council, I said, if we decided passive house was the way to go, and today, and every house forward that's built brand new or major renovation is going to be passive house standard, our houses last barely 10 years. That means in 10 years, every one of our community members would be in a passive house. That's all it would take. We just say, yeah, National Building Code is there until we adopt it. Well, what do we adopt? My community is Quebec, Ontario, New York State. Well, what do we adopt? Which one? Well, why don't we just make our own? We can. When I sat at the board at Passivhaus Canada, I explained to them the problems that we have and the struggles that we face. And I said, we don't have building codes. There's nobody enforcing them. We have to do it ourselves. National Building Code doesn't, we try to follow it, but we struggle. And I said, we could create our own code. And they were just floored. They were like, what? You mean they have a whole team advocating governments to change current building codes to make it passive to meet the 2030 requirements for building emissions. And we don't have anything. We can start from scratch. We can say, this is what we're going to build from now on. We just do an energy model and say, okay, for this 3-bedroom house or 2-bedroom house, this is the R values you need. These are the windows you need. Go ahead and just do it today. Because if the cost is the same, then why aren't we doing it? It's kind of a no-brainer. We know what housing means to us. Everybody knows. There's study after study after study. It doesn't matter. We all know. We all live in our communities. We all see what problems have. Nothing in your life can get better unless you have stable, comfortable, safe housing. That's the only thing that you can ground yourself and build from there. You're not going to go for that other job. You're not going to go back to college or go back to school or go get more training if you're struggling to make ends meet living in energy poverty. And you can eliminate it just by doing it a little bit different. And it doesn't really have to cost that much. And it has to come from the education. It has to come from your own community. I know what's available for my community, ICF, stick frame, whatever, and any of those materials that are readily available and easy and cheap to and can be brought in quite easily. I can use those to make a passive building. I can design a passive building, but I still need people to build it. And that's why I did the tradesperson course. And after the tradesperson course, it gives you enough of the fundamentals in the design to understand and build it properly. And it gives you that, I heard it earlier, the 20-80, 20% class, 80% hands-on. And that's the way this tradesperson course has been structured. And when I did, Ganawage came, they wrote it into their budget for 2020 and then COVID hit, of course. But at the board level, Passivhaus Canada, I presented this and I talked about it and I talked about the struggles and I talked about access to education. I talked about all of that. And then they decided to make it free for all First Nations, Inuit, and Métis across Canada. You can go online, you can take the online courses, you can sign up for the in-person courses, and it's free because they want to remove the financial barrier. And I didn't even know they did this. They made the decision, they voted on it as a board, and they excluded me from the decision. Well, they knew what I was going to vote for. So they wanted to keep me arm's length from it. So they decided, then they told me afterwards, and they even put a quote on there. But it's that important. It's just, once you get your fundamentals, this is how you build to building code. How do we do better? How do we take it to the next level? We're always playing catch up. R2000 came in, well, we got R2000, what, 30 years later? Every single time, it's like a full generation in lag. But the building code will keep changing until it makes us build passive. So why don't we just do it now? Why don't we just say that's what we need to do now, not wait for building code to push us there, but do it now. Building code changes every, what, 5-6 years? So you build it to code, and then 5-6 years after you move in, it doesn't meet code anymore. It's ridiculous. We're chasing our own tails here. For Ontario, anyway, there's a skills development fund, and Passivhaus is looking for a partner. So if any of you know who wants to be involved or have people that want to get involved and develop those skills, we're looking to use the Ontario Skills Development Fund in order to partner with somebody to deliver some of this training and access it and bring it to the communities. When we talked about going back to in-person training at the board level, because they pivoted to online training real rapidly, and they're like, this is great, so many people are going to access. I'm like, you know what? On reserve internet is slow, it's horrible. So great online, people who have fast internet, they can access it, and that's great. It opens a lot of doors. But a lot of communities don't have fast internet. They struggle. They can't do video conferencing. So how do you attend a training class? And they said, well, after COVID, they're like, we're going to move back to in-person training and still offer the online because we developed it. We're going to still offer it, but move back to in-person training. And I said, you know what? Every time there's in-person training, it's downtown Toronto, it's downtown Ottawa, it's downtown Montreal. It's always downtown in a city somewhere, downtown Vancouver. It's expensive. And I said, that's a financial barrier. It's a geographical barrier. I said, a lot of people from the reserve, they don't have the means to get there. And then they struggle with their council to fund them, to pay for them to go and stay downtown in a hotel, what, $300 a night or something, $250 a night in order to attend these classes. I said, you know what? Somewhere around every large city, there's a reserve nearby. I said, you could rent the facility, the recreation facility or whatever, and hold the classes there. The people downtown, they don't care. They have the means financially and the means to travel out of the city, and they travel out of the city every weekend anyway. So if they get out of the city, it's a treat for them. Well, they'll go to the community and take the class. But if you're delivering the class in that community, people that are there can attend it much easier. There's a lot less barriers in their way to get to that class. So if you're interested, I've made this big QR code. You can scan with your phone, connects you with the email and Milner, and contact her, get more information if you want to get involved and tap into this Ontario Skills Development Fund. I'm sure there's other ones in other provinces as well in order to get that skills training there that's desperately needed, because we know nobody is coming to our communities to fix this for us. It's not happening. You hear all the success stories here. It only happens when you do it yourself. People come in, they build it, they leave. They don't, no warranties, no nothing. They just walk away, and there's all kinds of problems that we're left dealing with. In my community, we have a contractor whose only existence as a business is the emergency repair fund. That's all he does, is go around and repair these houses. Emergency repairs, major renovations, new roof, new porch, new whatever, structural issues. That's all he does as a company. And he's good at it, but we could eliminate that if we just build them better, if we just build them to last. We could eliminate the energy poverty, the emergency shelters. If everybody lived in a passive house and you lose power, well, it's not going to freeze. It's insulated. Your body heat's going to keep it warm. It's going to have that resiliency to maintain its temperature for weeks without a heat source, because you're not relying on that energy. So anyway, I think I covered everything. So if you're looking for more education, more training, you can look to Passive House. They're offering it for free, as well as the Skills Development Fund. And I would love to see more tradesperson courses being taught in our communities all across Canada, because that's where we need it the most. That's going to have the largest impact, the largest change in housing issues and housing crisis is the people who suffer from the worst housing conditions. Thank you.
Thank you, Jeremiah. Does anybody have any questions? Surprise.
I know it's the end of the conference. You guys are all tired, been through so many classes, so many sessions.
Hello, thanks for the presentation. Just curious, I guess, on your opinion on, like, there's the double stud wall construction to kind of increase, our values within a wall assembly, as well as the exterior rigid foam where you can have your kind of vapor on the outboard of your interior construction so you can run all your services and stuff without penetrating the vapor. Just curious, in your opinion, what's the better construction assembly for something like this?
Like I mentioned earlier, it really depends on what your skill set in the area is, what's available to you, what kind of materials. Now, I've seen them do, they call it Larson truss. It's basically a floor joist that they put vertically on the outside of the building, and then they fill it with dense pack. It's pretty good. It works, makes a real thick wall. If that's the skill set you have, then that's what you need to use. And for us, a lot of people like ICF because it's fast, it's easy. Lego blocks, put them together, pour the concrete, and you have walls. So the ICF block, you can buy it in the 2.5 inch, which is code minimum, or you can buy it with 4 inches of foam on each side, and then add another 3.5 inch layer. And I think Nudura makes that product. It's called XR35. So you're doing the same labor. It's the same skill set. It's just the foam is a little thicker, which doesn't even make it heavier. So why not? Now, the young guy that I mentioned earlier, the certified tradesperson, he built a semi-detached 2-story passive house using those blocks. And when there was a shortage for ICF, because everybody switched to ICF when lumber prices doubled, he bought the XR35 Nudura and they showed up a week later. There was no shortage because nobody's using it. And per block, on a square foot basis, it was $1 a square foot more. So you're already spending $80 on a block. You're spending $81 and you're getting more than double the R value. It's just so simple and easy, but you got to look at what you have available. So if it's carpentry that's really available and everybody can, then let them use carpentry to make the passive house. Double stud 2x4, Larson truss, whatever you want to do. And I think that's what Harold Orr does is he puts the vertical floor joist with a strap at the bottom and then he fills it with dense pack. That's one way to do it. You can do the rigid foam on the exterior if it's available in your area. So looking at that wall assembly and what you have available and how to reach those R values that are required by the energy model, and then making that wall assembly for your climate, that's where you need to start using what's available to you. Because if you try to shoehorn in some other foreign technology that nobody's ever seen before, now you got to teach them the skills to build it, and you got to teach them how to do it right. Where if they already have skills, build on those skills, baby steps, a little at a time, and just keep building on top of that. So there's no cookie cutter. It's not easy. Just like the energy model, it has to be specific for your climate. There's no cookie cutter for that either. We've tried it. That's the building code, cookie cutter. Everybody gets the same. It doesn't work. We know it doesn't work. So designing for your climate specific, for your community specific. Every community can have their own building code. They just write their own R value requirements and do their own energy modeling. It's a little bit of money up front, but it saves in the long run. So look at the skills you got, utilize what you already have and build on top of that. It's really just a little bit thicker on the walls and more insulation.
Any other questions? Thanks again, Jeremiah. That was
Right,
great.
thank you. We kept time too.